In this video, I'm going to demonstrate how to integrate a provisioned TKG workload cluster with NSX Advanced Load Balancer. So by default, when a TKG workload cluster is provisioned, it's not automatically configured to use the NSX Advanced Load Balancer. This means we can provide granular configuration for our workload clusters to define which of the clusters utilize NSX Advanced Load Balancer, as well as the specific configurations that can be used for NSX Advanced Load Balancer, such as which networks are used, as well as, for instance, which service engine groups to utilize. So in order to define this configuration, a custom object is defined on the TKG management cluster called the AKO deployment config. And this object contains details of the NSX Advanced Load Balancer configurations we want to utilize, as well as a label configuration. So we can define which workload clusters utilize this configuration by defining a label on that workload cluster's cluster object. So you will see I'm logged into my Bootstrap machine, and I've split the window into two panes. On the right-hand pane, I am using the context for our workload cluster that we created, and I am doing a watch on the command kubectl get all for the namespace avi system, which is where the objects for our avi Kubernetes operator will be created. So in the left pane, I'm currently set to the context of the management cluster, and I can confirm this by issuing a kubectl config current context, and you will see that the context is currently set to the management cluster. So I can now query for the custom AKO deployment config resource that I mentioned before. So to do this, I'm going to issue a kubectl get, and I'm going to use the short name for the resource, which is ADC, and I'm going to check for that resource in all namespaces. And you will see that there are two configurations that are defined by default. At the moment, the labels that it's checking for as part of this configuration is for type equals management. So I'm going to create an additional configuration here that checks for the label type is equal to workload. So I already have a configuration file defined on the Bootstrap machine, which I've currently called install-ako-4-workload.yaml. And if I cat this file, we can see its contents, and we can also see some of the configuration relevant to the NSX Advanced Load Balancer. So the first thing you'll notice is cloud name, and that's the cloud name that we defined in NSX ALB. You'll also see here under cluster selector, we've got match labels. So this is the label that will be searched for. And if that label is defined on any of our cluster objects, the avi Kubernetes operator will be deployed automatically onto that cluster. You will also see configurations for the control plane network and the data network. And the network that we'll be using for this is tkg-cluster-vip. And you'll see a configuration here as well pointing to the IP of the NSX ALB controller. And then you'll see three additional configurations here. The first is the NSX T1 logical router, and that's mapped to the NSX T1 logical router that we've got defined in my environment. And the last two configurations are the network name for the node network, and that is the TKG-workload-logical segment that's created in NSXT, and that our workload cluster nodes are connected to. And then you'll see here service engine group, TKG-WLD-SEG service engine group, and that will be the service engine group that will be used to service any virtual services that are created as a result of us creating any Kubernetes objects of service type load balancer. So in order to action this against our workload cluster, there's two things I need to do. The first is I'm going to apply this manifest to our management cluster. And you'll see that that has been created. And if I do a get again, we'll see the object I just created. And then the second thing I need to do is apply that label type equals to workload to our workload cluster. So in order to do that, I'm going to execute a kubectl label cluster, and then the name of our workload cluster, which is TKG 160-WLD01-NSX, and the label we want to apply. So we want to apply type is equal to workload, and that cluster object is in the namespace TKG-clusters. So once I execute this, the label will be applied, and then we're going to monitor the right-hand pane to see whether our Avi Kubernetes operator is automatically deployed and started. So I'm just going to execute that now, and you'll see that our cluster has been labeled. So we're just going to monitor the right-hand pane now and see if our objects are created successfully. So there you can see immediately our namespace has been created. So avi-system has been created, and already our pod and stateful sets are created and running. So now that that pod is running, I'm just going to escape out of this, and I'm going to issue first of all a clear, and then I'm going to run a kubectl logs for AKO-0 in namespace avi-system, and you'll see that it has started up correctly and everything seems to be working. So our workload cluster is now successfully integrated with the NSX Advanced Load Balancer. And if we were to create any Kubernetes objects of service type load balancer, a virtual service would now be created automatically within NSX ALB to service that load balancer and provide an IP address from our cluster VIP network. In order to demonstrate the integration with the NSX Advanced Load Balancer is configured correctly, I'm just going to create a sample deployment which will create 5 replicas, so 5 pods containing a sample application, and I'm then going to expose that deployment with a service type load balancer. So we should see a virtual service created within NSX Advanced Load Balancer, and we should see the virtual service load balance across the 5 pods that are created. So I already have a predefined deployment YAML called hello world.yaml. And if we have a look inside that YAML, we can see that it contains a definition for a deployment. We're going to deploy 5 replicas, and the image we're going to use is a hello world application from Google Samples, and it answers on container port 8080. So in order to deploy this manifest, I'm going to run a kubectl apply -f hello world.yaml. And we can see that our deployment has been successfully created. So if I run a kubectl get pods, I should see 5 pods in running state, which we can see there. So I'm now going to expose this deployment externally, and to do that, I'm going to run a kubectl expose deployment and the name of the deployment, which is hello world. And I want this to be exposed via service type load balancer. So we can see that that command is being successful. So if I run a kubectl get service now, I should see our hello world service has been created and it's been assigned to an IP from the cluster VIP network. And I should be able to issue a curl against that external IP address on port 8080 and get a response. And you can see that the sample application has responded with hello Kubernetes. So I'm just going to switch over to the NSX Advanced Load Balancer UI to validate that the virtual service has been created correctly. So over in the NSX Advanced Load Balancer UI, under the Applications tab, we can now see that there are 4 virtual services. And we can see a virtual service for the deployment that we just created and exposed. So here it is, hello world. And if I expand that, you can see that our service is being load balanced across our 6 deployed nodes for our workload cluster. And the port that's being assigned is the defined node port on those nodes. So based on that, it looks like our integration is all working correctly. So that brings us to the end of this video. Thank you for watching.